Greetings everyone and welcome to another exciting episode of IT Pro TV. I'm your host Daniel Lowry, and in today's episode, well, we're kicking off our VCA 6 series. Joining me in the studio to help us out with that is our good friend and mentor, Mr. Ronnie Wong. Ronnie, welcome to the show, sir. How's it going today?
It's going well today. It's another great day to be right here as we kick off on a new series, taking a look at the VMware VCA, which stands for, of course, the VMware's Certified Associate in Version 6 exam. And what we want to do is we want to make sure that you understand some of these different virtualization concepts as they relate to data center virtualization. So this is one of these exams that will really help you to at least get started and understand the concepts inside of data center virtualization. But as we get started, we want to actually just do a little bit of a review, because always great to actually do a small review of course, initial virtualization concepts. And you might be wondering, like, why? We know that IT Pro TV has a series on it, Ronnie, so why don't we watch that? Absolutely a great idea. By all means, make sure you do check out that series as we go through and we just show you some of the basics in virtualization. But because we're actually beginning a new topic, reviews always a great thing, because we actually understand something around here at IT Pro TV. The idea of repetition leads to retention, right?
That's right. That's exactly right. And it never hurts to go back over things and to set the foundation, set the stage, as it were, so that we're all fresh in our mind. We've got all of our terms squared away. We're all working with the same vocabulary as well. That always helps with that. That being said, Ronnie, where do we begin with our understanding?
Yeah, a great idea here is to actually simply begin with the idea of physical hardware, right? So most of us are actually used to working with computers and even working inside of a network shop in which we have networking and we have people working on desktop computers and even servers, but we may not be familiar with the concept of virtualization. So let's go ahead and start right there and understand at least what we're actually going to be doing. So when it comes down to the fundamentals, we're looking at a computer or a server. Let's take a look at my screen here, and that way we'll talk about the diagrams that will actually help us out. So when it breaks down, it's not really about the hardware that we're concerned about, but it's actually giving the understanding that you know what's going on that hardware. So we know that we have underlying computer hardware, right? We have a single server or a desktop computer if you want to, but I'm going to use a server in this example since we're talking about data center here. And when we take a look at that, it's the idea of the physical hardware that we tend to deal with. Whether you're talking about a desktop computer or a server, itself that you tend to buy from one of the vendors that's out there, you're generally going to have CPU or multiple CPUs. You're going to have RAM. Now, when it comes down to servers, you're going to have a lot more RAM than what you generally see in a desktop computer. So when I start talking about RAM in this size, we're talking about quantities usually about at least 16 and sometimes 32 and going up even higher than that as well. And then when we take a look at storage, we start talking about storages in the double digits as far as terabytes go a lot of times in today's world. Now, Daniel and I, we actually started in days in which all of a sudden when we start taking a look at the idea of the CPU, we started off with single core x86 types of server environments where the maximum hard drive was like 128 gigs, and we just thought, man, that thing's gigantic, and 4 gigs of RAM. And we just thought it was insane.
I think my first computer had like 8 megs of RAM in it. And I was like, this is a beast. This thing is a 133 megahertz processor. That's insane. We've come a long way, right?
We really have. We've come an incredibly long way. But when you take a look at it, it's basic hardware, okay? So, but for you and I to be able to operate in that hardware, essentially what has to go on is that we actually interact with it through a layer of software. And so does everything else. We're talking about applications, and everything else tend to do the same thing too. So as human interaction goes, if just the hardware itself, you're just taking a look at a big, gigantic, expensive paperweight when it comes down to it, right? So if you don't have any way that you can actually command the CPU to run operations, and you can't tell the CPU to pull things out of RAM or to pull things off the hard drive, you can't do so. So an operating system is actually what helps you and I to interact with the hardware. And also then, when we need something specific to happen, we tend to, of course, purchase applications that will also communicate through that operating system to get the hardware to do the processing that it needs, okay? So when we take a look at something just like that, okay, well, that's the way that we actually understand computing, and that's a great place to actually begin. Without this solid foundational concept itself, the idea of virtualization seems like magic to most people, okay? It really does. But when we start understanding this, and this layer that I actually have really in colors here, and I'm just showing app 1, app 2, app 3, it can be any application that you want to. what ends up happening is that we have exactly this result. We have a single operating system that controls access to all the available hardware. Now in that sense, that works perfectly fine, but we find out something after you actually start using that amount of hardware for a while. Most of us do not ever tend to overtax a computer. Now if you're doing things like we do here at IT Pro TV, we overtax computers every day, and one of the big processes that we do is we do video encoding, right? So we were looking at the other day, we had one machine that was running slow that we were doing video encoding on, and we took a look at the activity monitor on that Mac, and the CPU itself was reading at 500%. I mean, that's pretty impressive, 500%. That is beyond impressive here, and so that shows you that, yes, there is a possibility of overtaxing machines. But in today's hardware environment, most desktop users aren't going to overtax machines at all. Okay? Usually the reason why is that the applications that they're accessing may use a small percentage of it, and the same thing with just the operating system itself. You may get 15 to 20% utilization out of that hardware that you have available. So the problem that we have then when we move into the realm of production environments as simple is that it starts happening even at the network and at the server levels too. The very fact is in an Active Directory environment, right, you install the operating system, you might install 1 or 2 roles on that one machine, and that might take up 15–20% of the actual operations on that one computer. Somebody else says, hey, we need to bring up another file server. What do? We go out and buy another server, we install that role, we do everything that we need to, but we're really only taking up that amount. Storage is where we tend to focus in more on. So when we start taking a look at that, what ends up happening, whether it's a workstation or whether it's a server, we end up actually not utilizing all of the actual performance that we actually can have out of that computer. Okay? So you might be wondering, like, why in the world is that important? Because that actually goes to gigantic overhead, right? The very fact is you can buy 5 or 6 servers, and only after you actually buy 5 or 6 are you really utilizing 100% of really the equal performance of one computer itself. So that's why we wanted to get to this point here, okay? And that's what essentially ended up happening, is that a lot of companies ended up saying, look, we've got 5 or 6 servers, but they're essentially running like DNS or DHCP on their own, or you know, just a file server or just a domain controller. And don't get me wrong, those roles are essential and they're important, but they really take up a server to be running 24 hours a day, 7 days a week. And the problem is we're not actually utilizing it, so it's a big cost overhead. So the reason why that's important in the realm of virtualization is what virtualization really does. So if I flip on over here, I made it a little bit more colorful and hopefully a little bit better here, is that we see 2 things happened during the early stages here, right? One is the one that you see over here on the left-hand side, and this is what I remember coming first. Now, I'm not going to say that the other one wasn't around because I don't really know historically or not, but what I'm going to say is this is the one that I'm actually used to right here. What started to happen is that people realized that there's a lot more utilization that you can get out of the hardware. So what they did is same thing, hardware and an operating system, but then said, look, we can actually install an application that we're going to call a hypervisor, and that hypervisor will essentially lie to another operating system, okay? So that's the way that I term it. It will lie.
It's immoral.
Yeah, it is. It is kind of a little bit immoral there. But what it does is it tells another operating system that I can go ahead and show you a whole computer, even though it's not really. You're actually still running on the actual one physical hardware, but it can essentially lie to it. The hypervisor runs an application, and then you can install another operating system on top of it and another operating system on top of it, and even more. It depends on how much physical hardware that you have, especially RAM and, of course, storage space goes. So that way, I can do that. And we use this type of hypervisor just about every day here at IT Pro TV. Most of us, at least on the shows here, we're running Mac computer. I think all of us do. Now that I think about it, we're running on Macs, and we're using a product called VMware Fusion that allows us to do that. And this is exactly the product that ends up happening, is that we install that hypervisor, and then we can go ahead and actually build these machines, and then I can interact with them as if it's actually running its own machine. So that means that even though I have one piece of hardware, I can be running 3 or 4 different operating systems, interacting with them, doing everything that I need to, okay? So that's kind of the basic beginnings when we see it. Now, the hard thing about it is that it's still overhead. You still have to actually make room, of course, for the underlying operating system itself. you still have to actually run applications in the background. So on mine, I'm still running my email client. I'm still running that VMware Fusion. I've actually got a Windows 10 computer on there, and I've got a Server 2012 for SQL running a little bit later as well. So, I mean, I've got 3 different operating systems on this one computer at one particular time, okay? So that actually works, and this is the one that I am more familiar with, at least from the beginning. I started off using the Microsoft Virtual PC 2000, and I think it was 5 at that point, but it was actually 2007 was the last edition that was out there. And actually figuring this thing out and figuring out how I can actually do that and installing applications. And it just runs like another computer that you're actually on, and everything actually works here when you start taking a look at it. So when you do something like that, that's what's called a hosted hypervisor. Now, I'm using a particular term here, okay? The reason why I'm using hosted is because in terms of the VMware type of vocabulary, they call it hosted. Everywhere else on the planet, you're going to call it a type 2 hypervisor, but in VMware, they call it a hosted hypervisor is what you hear about.
I mean, that is a little more descriptive, to be honest with you, to say it's hosted, because if you look at Ronnie's diagram, what's happening there? He's saying, I've got my hypervisor, but it's sitting on top of my operating system, right? So I've got all these other operating systems that are running through my hypervisor, but when it wants access to resources, the liar, right, that we love, our little liar here, our little hypervisor, it kind of goes back to the operating system. He's like, hey, can you access that RAM for me, and then send that back? So he's really got like the operating system is its enabler, if you will, right? It's enabling it to lie to the other operating systems, say I have access to those resources for you. That is what we mean when we say hosted, because there's already a host on there, and it's enabling the hypervisor to work. Is that well said, Ron?
Yeah, that's exactly a great summary of what we tend to look at when we start seeing it. Now, of course, then when you start moving into the realm of network support or domain support, right, the idea of domain admin support, well, you might go, well, that's great for a desktop operating system. It works perfectly fine, but I need this, but I need to actually be able to run servers on it. And when you start doing that, servers require a lot more hardware, a lot more of everything to actually run, because they're operating 24 hours a day, 7 days a week. They do not turn off. So somebody else was actually able to come up with the idea of what we call a bare metal hypervisor. And again, I'm using the VMware term specifically here, because when you face it on the exam, you might go, well, Ronnie said type 1. I don't see type 1 anywhere on. I understand, but it's called a bare metal hypervisor in terms of VMware vocabulary. So make sure you note that as well. Now notice the difference, and I wanted to put them side by side so that we can compare them just a little bit as well. Notice what's missing from here when you take a look at the stack, right? We have hardware on the hosted one, and operating system, and then a hypervisor as well as apps running, and then you have your, of course, apps running on top of that hypervisor. Over here on the right-hand side, notice it's hardware, and then you have a hypervisor itself, but notice what we're missing, which is that underlying operating system. And so that means we can actually run that kind of lying piece of software here. That's exactly what it is here. And it actually then can run operating systems within it. Well, why is that important? Well, it's important because if you take a look at the minimum requirements, let's just say for a Windows operating system, today it's probably at least 2 gigs of RAM, requires a 60 gig hard drive, requires so much for it to run, and that's just for it can run. And then every virtual machine that you add in from that point would also do the same thing. Most hypervisors tend to actually be under 200 to 300 megabytes in size itself. The whole thing, the hypervisor itself, and also in the amount of RAM it takes is insanely minimal, okay? To the point where it really doesn't even take any more than that. Usually about 256 megs of RAM, a bare metal hypervisor tends to run and be able to do everything that it can. What does that give us the advantage to do as far as a domain admin or a network administrator goes as well? It means that we can actually create other machines, and a lot more of them, because we actually only have the hypervisor. We don't have to worry about adding in extra stuff here for the underlying operating system to actually end up running. Okay? So notice that on the bare metal hypervisor, it's not depending on a host operating system anymore, and that means less overhead. The other thing that it gives us the advantage to do as well is that it actually gives us also kind of the same resource management capabilities as what we would actually have here in the hosted one, but without having to depend on the operating system to run as well, okay? So if you were to take a choice between them from the VMware perspective, okay, and that's what we always have to keep in mind here as we're getting ready for the exam, why would you choose one over the other? If you need to access more hardware and more resources, absolutely choose the bare metal hypervisor. By far, that's what you're going to choose, okay? But is there an opportunity? Is there a time when you're not going to choose that bare metal hypervisor? Well, not necessarily, but the only real requirement here, when you start actually saying, when would I use a type 2 hypervisor or the hosted hypervisor, is going to be if you actually find out something about the machine that you're running it on. Is that the bare metal hypervisor that you're actually trying to install says, look, we don't support that hardware, okay? So if you find that out, if you actually go, look, there's no driver support for it, there's nothing that you can do, and you still need to do some virtualization, what it normally is going to mean is that you're going to install an operating system on that server, and then you're going to run a type 2 hypervisor. Now, type 2 hypervisors do just about the same capabilities. To a point it can, okay? But remember that when you're in that type 2 hypervisor, you are dependent upon that operating system operating the way that it needs to, up to date, doing everything that it needs to, and that you're depending on that operating system to never get corrupted. So you've got a lot more to have to deal with, but that's usually the choices here. So most people do ask, when should I choose one over the other one? Usually here's the two scenarios that you have. You need more access to the server side, and as far as more machines need to be built, more stuff needs to be done, more than likely the choice is always going to be this idea of the bare metal. But if you do have hardware that's specific, that's customized, whatever it is, you don't have that ability to do so, well, you're probably going to end up choosing this idea of the type 2 or the hosted hypervisor itself, okay? So that's what we talk about in terms of fundamentals when you start taking a look at the idea of the movement or the foundation of virtualization, right? We take essentially bare metal hardware or whatever hardware it is, and we actually are creating essentially a software version of that in these hypervisors is what we're taking a look at, okay? So the reason why that's important, right, is because when you think about what a hypervisor does, that's what happens here. And so here's what the result should actually end up being inside of a hypervisor, okay, is that every VM, which is what we call a virtual machine, right, that's created, what they will end up seeing is through the hypervisor is that they'll see their own hardware, okay, every bit of it. They'll think that they're actually on their own machine, on their own hardware, on everything. And so it doesn't matter. As long as you have the resources available on that hosted physical machine, that means that every machine will see its own, okay? And it also means it's isolated. In other words, the VM over on the left-hand side doesn't necessarily know about the VM over on the right-hand side. So they're not saying, hey, look, you're taking up my RAM, you're using those resources here, and I need it back. So they're not actually in contention. And the way that we assign that is really all through software. So when it comes down to it, the hypervisor is essentially that. It is creating a software version of our hardware, and when it does that, every VM actually looks at that software and says, yeah, that's my hardware, okay? So that's why I say it lies to the actual operating system, because every operating system that ends up running on it goes, yeah, that's exactly right. It doesn't actually know that it's actually being lied to a lot of times. And you might say, well, what's the benefit of that? Why would we do that? Well, notice what happens here if I'm to do something, and let's see, Daniel, you know my line drawing ability is legend domain here.
Oh yeah,
so,
look at that.
Yeah, isn't that gracious and beautiful here? But even if this VM then, right, happens to crash, right there, I mean, heaven forbid it actually stay red. I mean, but even if that VM were to crash, notice that what we still have is what? The physical operating system still being able to operate, and the other VMs that may be out there still being able to operate. If we only had it without virtualization, right, that app may crash, but if the operating system crashes, you don't have access to anything. So the idea of actually being able to do this, right, it has some benefits that we can actually attach to it here. And so that's some of the things that we want to make sure that we understand as far as the basic operations go, right? So by being able to do this, you start seeing where now, inside of a domain, right, being able to create servers in which you go, I can mimic essentially that server's hardware and actually run another server on top of it? Yes, okay? That is where we actually want to begin here, because it really does. It means that as long as there's no physical damage here, okay, and actually even if there is, to tell you the truth, the software actually mimics the areas that it doesn't. It just says, here's a complete set of hardware that you actually said that needed to be done, and that's what has to happen. So even if there's some hardware failure, a lot of times even this, the VMs don't actually report that, hey, there's actually RAM missing, or you know, the hard drive. It just tells you, hey, the hard drive's getting smaller because you don't have enough space, but that's about it. So it's one of those unusual things that we have to think about when we start thinking about the basics of virtualization here, okay? So when we take a look, let's take a look at some of these ideas of benefits in running a model like this, right? When we start taking a look then at virtualization, okay, organizations can reduce the hardware and use hardware more efficiently, and the reason why is that we can run multiple VMs on the same physical host. Well, this should make sense. Remember at the beginning we talked about that you know, when organizations weren't using virtualization, you might have bought a machine for a domain controller, you might have bought one for a DNS server, you might have bought one for a DHCP server, and stacked them all up inside of your rack, and each one install the same operating system on it, or different, it depends on you. Put those roles on there that you needed to, made them operate, and that was great, that was fine, and that actually ended up working. But in each one of those, you're only utilizing just a very small piece of the actual physical hardware. So every server essentially was overpowered to the extreme, okay? Well, by using something like the hypervisor and beginning that concept of virtualization, I can now take one bare metal hypervisor and create my own VMware domain controller, my own VM DNS server, my own VM DHCP server, my own VM file server, create all those and actually make them run on a single physical machine if I want to, okay? Now, when you do that, remember, it still can actually have that failure of the hardware, don't get me wrong, but overall though, one failure of one of those servers doesn't necessarily affect, as far as the performance goes, the failures of the other one. So it actually gives you what we call a more efficient utilization of that hardware, and that's one of the big benefits that we also have as well. The other one is what we already talked about as well, that isolation that we actually want to take a look at. Remember that every machine actually sees their hardware as theirs. They do not actually have to wait for anybody else to actually get access to it. Each particular machine actually uses it as their own, okay? And apparently I doubled that up, so we didn't need that. And then lastly, what we're also going to see here as well when we start taking a look at it is that there are also, of course, business cases for this that will actually help out tremendously as well. So when you start seeing the idea of each isolation there and you start turning around in terms of benefits for a business, there are a few of them that we can actually do here. And I did not type these in, which I probably should have, but let's go ahead and talk about them as we're going on, okay? So one of the other ones here, let me get the same one, is Arial, I think. Oops, well, maybe not. Arial, if I can find it. Arial, there. Arial Hebrew, how's that? That won't work for me. There we go. Arial, and of course it's black. Why wouldn't it be? So here, let's talk about testing and development. We'll just add that one in here just briefly. So when you start taking a look at some of the benefits here, okay, Daniel, if you were to come to me today, okay, or actually let's move back 10 years ago, and you were to say, Ronnie, we need to set up some different servers for testing this new application deployment, okay? And you told me about 5 or 6 different applications to do something like that. I would have to actually go about it by what? Getting applications and multiple servers, right?
Oh yeah, you'd have to buy all the hardware, you'd have to get the operating systems installed on said hardware. Then not only that, you need the development environment necessary to create the development stuff that you want to do. So if you're trying to code in C++ or Java or whatever, all that's got to be put on there, and that's got to be done by you. That's going to take up resources. You got to rack it in the server rack. It takes time, takes space, takes power. You got to plug it in, turn it on, run extra cables, get it hooked up to the network. I'm talking about a lot of administrative effort just to get that test bed set up for you.
Yeah, it is amazing that when you think about it, you know, as far as a business goes, if somebody said we really needed to run this testing environment because we want to get into this area of the business or whatever it is, it could really cost a ton of money just getting that testing environment set up. Well, by using something like virtualization instead, if I have plenty of space on my server that's actually available, right? And all we actually need, if everything is actually coordinated in the way that it needs to, the networking's there, the hardware's there, well, now all Ronnie has to do is spin up maybe 3 or 4 different server VMs and run them at the same time. I can even put them on a different virtual network so they don't affect my business traffic, my actual production network as well. So now all of a sudden you start going, wait a minute, we can do that? Yes, you can do it and isolate that particular network by itself, and that way you do not have to worry. So even in a testing and development environment, this is the way to go. This is what we do at IT Pro TV when we start doing things like the server shows, right? In the server shows, you're running 2 or 3 different servers. You need to verify that they're working along with a client. Well, we're actually doing a testing environment to prove the concept that we're actually trying to develop and trying to show you as well. And it really does. It's either that, or what we have to do is we have to pull out some machines, get them all set up over on a wall, and make sure they're networked together, verify that we can connect to them. Instead, using that virtualized environment, we simply actually already have all that stuff connected because it's all done through software, and that actually does help us out tremendously.
And Ronnie, one of the cool things about that is once I create that virtual machine, it's kind of like a file, right? It's this self-contained entity, and if I've got the storage capacity, I can make a copy of that file and I can stick it over in my storage. So when my dev team gets done testing their environment, and you say, okay, we're done with that, you can blow it away. Well, I still have a copy of that. They say, hey, now we want to test it in Python. Can you build us a Python? Sure, not a problem. I've already got the base virtual machine that I need. I just throw it in there and add Python to it, and I'm also even faster than I was before because I didn't have to build the operating system. So there's another speed advantage with working with virtual machines.
Yeah, there's no doubt. And the speed advantage is what we're also talking about when it comes down to the business case. Even in a testing and development environment that might take weeks for us to actually be able to do, most of the time, especially in a production environment, when we need to bring up a server, it did. It took us ordering that server, waiting for it to come in, making sure that the operating system was actually, done the way that we want, getting everything all together, installing it, putting it into server rack, hooking up network, verifying IP addresses, getting everything done the way that we wanted to, and that took a lot of time. Well, in today, the way that the actual virtualization helps us to work a bit faster is that all that is done and we configure the software. We tell the virtual machine how many CPUs we need, okay? We tell the virtual machine how much RAM we want this thing to run in. We tell it how much hard drive space are we willing to work with. And then, if we have everything set up like through a deployment server, we can deploy it right to that thing without ever having to actually buy any additional software, get it up and running probably within a couple of hours, and now you are ready to go. So there are actually speed cases here and business cases that we might see the idea of rapid deployment. The idea of actually being able to take the environment that we have in which we might actually have bought an application, right? And that ran insanely slow on regular desktop computers. Let's just do that. That's a great case scenario here. An application in like everybody's desktop computer, this application is just overwhelming. We can't run it, okay? We know we need to upgrade everybody's desktops. Well, we might even be able to go, look, let's virtualize the thing, give that particular VM whatever it actually needs, and allow people to do like a remote desktop connection into it, turning it into a terminal server. And now that application says, look, I've got 4 CPUs, I've got 4 gigs of RAM, I've got everything that I actually wanted here. And now we actually go ahead and everybody actually has access to that, and that's what they actually feel and see. And so you have that business case. And of course, what we're actually focusing in on, okay, as far as our show goes, is what we call DCV. Now, I want you to get familiar with that acronym here because, of course, in virtual and VMware here, that stands for Data Center Virtualization. Okay. Now, the reason why I'm actually doing it like this here is that we want to establish this idea of benefits here. Is that we focused in on really the idea of the server, right? An isolated unit or a desktop, a very isolated unit. But data center virtualization means that we can actually virtualize more than just the idea of a single VM. Don't get me wrong, a VM is kind of the core, the core fundamental technology that we need, okay? It really is. It's all about those VMs actually running. But believe it or not, when you start talking about data center virtualization, you're now actually moving just away from just the VMs to now talk about virtualized networking, virtualized storage, virtualized management of platforms that are just incredible.
It's a private cloud environment, really.
It is a private cloud environment in which that sense here, it means that you can actually manage it very easily as well. Okay, so that is the whole goal of virtualization as far as the benefit goes, is that when we actually try to work with everything in the physical level, right, it's each iteration, each server I've got to touch. But when it comes down to virtualization, a management console, regardless of where it is on the planet now, where it is in my network, whether it's on the other side of the country or whether it's here, I can open up a single management portal inside of that virtualization, be able to access it and manage it all at one time as well. So there's tons of benefits to the idea of actually starting and establishing the concepts of virtualization. And what we're going to end up finding out is that VMware is one of those solutions that we can absolutely use here as far as virtualization goes that may actually show us a benefit beyond what we could have actually imagined.
Yeah, and a great solution at that. I've worked with VMware for quite some time now, and it's been a wonderful environment to play around in. And I'm looking forward to doing this show with you, Ronnie, and now that we're all on the same page, we understand all the terminology, our language is going to be consistent, we can now really begin to dig in and see what VMware has to offer for us. So look forward to that, Ronnie. Is there anything else you'd like to add before we close the show?
Well, not in this episode, right? But we still have a little bit more of fundamentals that we're going to cover as we get more into the data center virtualization side and show that. Because we really did focus in on isolating that one unit. We're going to talk about that concept a little bit more, and then we're going to jump into some VMware stuff. And again, getting familiar with it is the key to actually being successful on the exam. So we're going to dive into showing you all the management concepts that are there too, at least briefly, and make sure that you understand them.
All right. Well, thanks for stopping by, Ronnie. Thanks for explaining these concepts and terminology to us. Hopefully you guys got a lot out of this episode. We look forward to seeing you in the upcoming episodes. Join us then. As for this episode, we're going to go ahead and sign off for IT Pro TV. I've been your host, Daniel Lowry.
And I'm Ronnie Wong.
And we'll see you next time.